Preparing for MBA exams can be overwhelming with so many concepts and questions to cover. So that is why I have curated this video containing 5 of the most repeated questions in the term and exam along with their answers. Yes, this video is designed to save your time and boost your confidence. How did I make this list? By carefully analyzing the past term and examination papers so that you won't have to start from scratch. Oh, don't have the time to go through this whole video to find out the answers? No problem. Log in to www.anusclassroom.com and purchase the concise revision friendly answer scripts that I have prepared for these 5 questions. It is ideal for some serious last minute learning. What do you understand by information system? Describe the various types of information system. An information system is, you must understand, more than just software. It is a combination of people, technology, and data working together to collect, process, store, and share information. So, this information system as is helps organizations make better decisions and communicate effectively. Now, there are different types of information systems, and each of those different types serve a unique purpose. So first, let us look at transaction processing system or TPS. Let me write that down for you. TPS, transaction processing system. Think of this as the system which records the day-to-day business activities like sales, billing, or payroll. So they handle large volumes of transactions quickly and accurately. Next is the Management Information System or MIS. These systems are designed for middle management. They take data from various departments and consolidate it and provide structured reports which help managers monitor performance and make informed decisions. Then we have the Decision Support System or DSS. These are more interactive. They provide managers with historical data, real time information, and analytical tools to solve complex problems or answer specific questions. For top level executives, we have what is called an EIS or Executive Information System. This provides a high level overview of the organization's performance, usually in real time, helping executives make strategic decisions. Now, moving to the office productivity part, we have office automation systems which automate everyday tasks like emails, word processing, spreadsheets, and scheduling, making work more efficient. We also have Knowledge Management System or KMS, which captures and shares organizational knowledge, turning tactic knowledge into accessible insights to foster innovation and learning. You might have seen what is it called? You you might have heard Confluence, like in some of the projects which I've worked, they used to keep their our knowledge base was in Confluence. So any new thing that we create or any new product that we launch, all the data related to it, like all the user manuals and things like that, we put it in Confluence. Similarly, we have other platforms also, like we have SharePoint. Microsoft SharePoint is there where we put in our details, like all the knowledge articles are put in over there. So these are all KMS or knowledge management systems. There are others also. These are the two knowledge management systems that I have used personally. Okay, so another interesting type of information system is the expert system. This is a system which mimics human expertise in a particular field using AI techniques to give advice or recommendations. And in today's global organizations, we also have what is called distributed information system, DIS. Okay, distributed information system, which is also very vital because they allow teams across different locations to access shared data and applications seamlessly. There is also ERP, enterprise relationship, enterprise resource planning, ERP. This is also another type of information system. It integrates multiple business functions like accounting, sales, procurement, and such into a single system, providing real time information on the resources. Enterprise Resource Planning System. And we also have what is called as CRM. Salesforce is a CRM, Customer Relationship Management System. It helps organizations manage interactions with customers, improving their marketing, sales, and customer service. So, in short, Information systems are everywhere, and they range from simple transaction records to complex AI based decision support systems, each type serving a specific purpose. But together, they keep an organization running smoothly and help it make better, faster decisions. So, that was a quick overview of information systems and their types. Hey, if you're enjoying this session, take a quick moment to subscribe to Anu's Classroom and turn on notifications so you will never miss an update. Your likes, shares, and even a super thanks or sticker are little boosts of encouragement that help me keep creating and growing this channel. You got any questions, ideas, or suggestions? Drop them in the comments. I love hearing from you and I'm always here to help however I can. Now let's head back. System software and application software are computer programs. Distinguish between application software and system software. So, system software and application software both are computer programs, but their purpose is very different. So, let us start with system software. This is the software which manages your computer's hardware and provides a platform for other applications to run. So, system software examples: Catalina, macOS, Windows, Linux, system software. Sorry, Windows, Linux, right? These are all system softwares. S- Whichever operating system your computer is running on, that is system software. Also, if you guys have some computer knowledge, you have studied computer science in 11th or 12th and all, you might be knowing about drivers, like your any external thing that you connect to. Maybe it is your printer, scanner, whatever it is, where you have drivers for it, right? So those drivers, the compilers, assemblers, all of these are system software. It usually gets installed automatically whenever you set up your computer, and it runs in the background to manage the hardware resources and provide essential services. So whether you can see it or not, when you plug in a mouse, or when you, even if you're using a Bluetooth mouse or you're using the keyboard, the reason why your keyboard in your laptop or computer functions properly is because of a driver software, and it is a type of system software. So you can think of it as the engine that runs under the hood of a car. Without it, the car is not going to run, no matter how fancy the dashboard is. Correct. Now, on the other hand, we have application software which is designed for specific tasks which users want to accomplish. Like, say, for example, your Word, Microsoft Word, or your Excel, or your PowerPoint. All of these are softwares, application softwares. Application software is installed according to the user's needs and directly interacts with the user to complete tasks. So, if you're coming to our car analogy, where we equated system software to the engine of the car, this application software can be thought of as the GPS or the entertainment system, or AC. The AC in your car. It is useful for specific tasks, but it depends on the engine for functioning. So, to sum up, system software manages the computer's resources and provides a platform for applications. And application software uses the platform that is provided by the system software to perform specific tasks for the user. So, both are essential for a computer to operate efficiently, but their roles are distinct. One works behind the scenes and the other works in front of the user. System development life cycle mainly consists of 7 phases. We are asked to name them and explain any 2 phases in brief. So I'll be explaining all 7 in brief for you guys. So what is this system development life cycle, or SDLC? This is a structured framework that guides us through the process of building and maintaining information system. It is what ensures that projects are completely completed efficiently on time and it meets the user's needs. So there are 7 main phases of SDLC. Let us list down one by one and we will look at it in detail. First is planning. The next is analyzing. The third phase is design. Then the fourth phase is implementation. Fifth phase is testing. Sixth phase is deployment. And the last but not the least phase is maintenance. So, what is planning phase. This is where everything begins. This is the first phase of STLC. We define the project's objectives, we figure out what problem we are trying to solve, and we conduct feasibility studies. Basically, in this stage, we are checking if the idea that we have is doable or not within the budget and the time we have. So, we have to set up a very clear roadmap uh, for the rest of the processes. And whatever roadmap we are preparing in the planning phase is what is going to guide us. So, a blueprint of what we are trying to achieve and how we are trying to achieve it is created in the planning phase. The second phase is the analysis phase. Here we dive deeper into understanding the problem or the opportunity we have. We gather the requirements from the user, we define the project's scope and create a conceptual design. So you can think of this stage as understanding exactly what the user needs before building anything. The third is the design stage. Here we convert the requirements that we gathered during our analysis phase into a blueprint. So this includes developing the technical specifications, designing the software architecture, planning the data structures, and sketching out user interfaces. So it is like drawing a detailed construction plan before actually building a house. The fourth stage is implementation. This is where the actual action starts. Developers write the code, integrate the different modules, and create a working system here. And this system is then installed in its operating environment, and initial testing gets carried out. So that leads us to the fifth stage, that is testing stage. Here we check everything. Does the system work as expected? Is it reliable? Is it fast? Is there any bugs or issues that can be fixed? Are we able to fix them? All of these things get done in this phase, and therefore it ensures that the system meets all the requirements before it is finally deployed into production. So this is the deployment is the sixth stage. Here the system is now installed for real world use, and users will be trained on how to use it, and support will be set up to handle any early issues as well. So it is like handing over the keys after making sure the house is ready to live in. And then comes the seventh phase, which is the maintenance phase. The journey does not end after deployment. Maintenance involves monitoring the system, fixing any bugs that might still arise after using it for a while, updating the features and making improvements as user needs or technologies change. So in summary, SDLC ensures that developing a system is not just a haphazard process. It's not like chuck it up a mile chatur kind of a process, but a step by step journey from planning and analysis to design, building, testing, and finally maintaining a reliable product. And if we follow these phases, then it will reduce the risk, save cost, and create better systems which truly meet the user's expectations. What are data models? How will you classify the data models? Explain them briefly. So, to simply put, a data model is a abstract representation of real world entities, their attributes, and the relationships between them. So, you can think of it as a blueprint which shows how data is going to be organized, how it is connected, and stored in a database. Data models make life easier for developers, business analysts, and managers by representing complex information in a well structured, understandable format. Now, there are quite few models or types of data models. The first model is Entity Relationship Model, or ERM. This is probably the first model that you are going to encounter when you are learning databases. It uses entities like, say, students or products, and their attributes like maybe name or price, and the relationships between them, like whether you're if it's a student, are you enrolled, or if it's a product, whether it is purchased, to design a conceptual framework. So this is the entity relationship model in short. Then another model is the relational model. This is the most common model, data model, which is used in practice, and it organizes data into tables with rows and columns and links them using foreign keys. You can think of this as, consider a college or a school's database. There will be one table for all the students who are enrolled. There will be another database for all the courses, and then there will be a key to link which student has enrolled in which course. Right? You think of IGNOU itself. So that is a relational model. Then the third type of data model is called as the object oriented model. Okay, so here data is treated as objects. And just like in object-oriented programming, data is also treated as objects here. Each object has attributes, it has its own methods and concepts like encapsulation or inheritance or polymorphism, and it makes it ideal for applications that need to closely mirror the real world objects. The fourth type of data model is called as the network model. This model uses a graph or a network structure, making it great for representing many to many relationships. It is very powerful, but it can get complicated and sometimes it can also get redundant as well. Then the fifth type of data model I want to touch upon is called as the hierarchical model. This one looks like a tree with a parent-child relationships. It is simple and efficient for data which has clear hierarchy, like say an organization chart and all, but it becomes tricky if you need flexible relationships between entities. Then the last model I want to touch upon is called as the semantic model. Semantic model, you can RDF or OWL models. So these are modern models which are used for knowledge representation like semantic web or AI ontologies. They represent data as resources that are connected by properties, making them perfect for web-based and AI applications. So in summary, the data models, I can say as a one-liner, they are blueprints which ensure data is well organized and meaningful. Now, the choice of the model, whether you're going for ERM model or you're going for object-oriented network relation, which data model you're going to go for depends on your system's needs. So, if you need a simple hierarchy, then you will go for hierarchical model. If you want flexible relationships, then accordingly, or a web-based knowledge representation, then you might go for semantic model. So, whatever is your data requirement, accordingly, you will choose the data model. Picking the right model is always the first step towards building an efficient and reliable database. Metadata in a data warehouse is similar to the data dictionary in the context of a database. Explain in view of the statement the types of metadata. So let us talk about metadata in a data warehouse. So as the statement suggests, yes, metadata is similar to a data dictionary in a regular database. But what exactly is this metadata that we are talking about? Put it simply, it is the data about the data. That is metadata. Data about data. So in a data warehouse, metadata will tell us where the data came from, how it was transformed, and what it means. So just like how a data dictionary describes tables, columns, and relationships in a database, metadata in a data warehouse describes the source, the structure, and the purpose of stored data. Now, metadata in a data warehouse can be grouped into three main types. There are three main types of metadata in a data warehouse. The first type of metadata is the operational metadata. It deals with the source systems and describes things like the field length or the data type or source data structure. So, if you are selecting data elements for a warehouse, then operational metadata will be your guide. It is like reading the label on ingredients before cooking. Then comes extraction and transformation metadata. This is all about the journey your data takes. It tells you how the data was extracted from different systems, what transformation rules were applied, and how it was mapped to fit the warehouse schema. So you can think of it as recipe steps, how raw ingredients are transformed into finished dish. That is what this extraction and transformation metadata talks about. Then the last type of metadata is the end user metadata. End user metadata. This is for the business analysts and decision makers. It explains what the fields mean, how the tables are related, and it gives the context that is needed to query and analyze data effectively. So this is the menu description kinda. It helps users understand what is being served to them. So, in summary, metadata in a data warehouse is crucial for understanding, managing, and using data effectively. And just as a data dictionary guides developers working with a database, metadata guides both the technical team and the business users in a data warehouse environment. And without this metadata, navigating a data warehouse would be like trying to cook without a recipe or ingredients list. At least without a bare minimum, at least Shan Jio's videos. Any Malayalis out here who looks at Shan Jio's videos for cooking? I do. Oh man, that person is awesome. So it would be confusing and it is going to be error prone, right? Without any kind of direction. So this metadata that gives you that direction. It gives you an idea of what is what and what is where.